Everyone. Today we are going to start off our series which is called as Object Oriented Programming. I hope everybody was waiting for the series. I had got a lot of DMs asking for, to start off with this series. So here we are finally with this OOPS concept. So the way I'm going to do this series is that we're going to start off by understanding what exactly object-oriented programming means. All right. Then what is an object? What is in class? Okay. Then we're going to talk about all the different principles which are involved in object-oriented programming. Right. There are around 4 principles which are the building blocks of object-oriented programming. We're going to cover each and everything, and then we will for every topic I will try and discuss the most important interview questions which usually get asked, right? And one disclaimer that I will be taking object oriented programming, I'll be using Java as my main programming language, right? Nevertheless, the concepts are going to remain the same in other object oriented programming languages like C sharp. Only the difference would be the change in syntax. Okay, with that said, let's begin. So what is object oriented programming, and why do we even have this object oriented programming? What is the purpose? Is most of the people who are new to computer science background and are listening to this concept for the first time have in mind. So object oriented programming is nothing but a programming paradigm. Okay, let's say it in simple words. It's nothing but it's a way in which you can model your real world, so that why you have to model the real world, so that you can actually build and test solutions for the problem. Now, might be this is not making much sense because this is again a textbook definition. So let's try to understand what this really means. So I hope everybody is aware of architects. What is their entire job? Their job is actually to design different buildings and landscapes, right? Now, when they design a building, suppose you give a contract to an architect and you want to, let's say, design a building, right? That might be some corporate office. So what does the architect do? The architect will create a sample model, like how, what his design will look like for this corporate office. He might create a physical dummy model out of it, right? Maybe made up of cardboards and stuff. Or else, now because of the digital world, he might have created a 3D model in a software. Okay. So why does he do that? He or she must be an architect, does that in order to model, in order to basically show this real, like what would a building look like, right? He wanted to show this in the form of a model, whether it's a physical model, a smaller one, or else it's a software model. The entire reason is he's trying to model the real world into the into his model, so that now as for his clients, now they can actually have a look at the model. They be able to tell him what changes that model needs to be done, and then you can take that as a blueprint. Okay, and then you can give it to the construction workers, and who can start off with the building and construction of the corporate space. Okay, same thing, imagine same thing we are going to try to do in the software world. In software world, what are we doing? We are creating different softwares, right? Why are we creating different softwares? Because we want to make life easy. We want to make our life easy. So basically, we are solving real world problems, correct? So if we are solving real world problems, we also have a need to model the real world, right? We need to model the real world in our software, in a program, right? Because when you have to interact with a computer, you're going to write simply a program, right? So when you have to solve problems for the real world, right? You want to create softwares which are going to solve problems for the real world. You need a way to model your real world cases into a software or in a program. Correct. Now to do that, we need to have some concept, some paradigm which will help all the software engineers to achieve this modeling, and that is beautifully done by object-oriented programming, in which we model the real world, so that we can now create a we can now you have a model world in front of, in terms of your software. Now you can might be solve your problem, test your problem, and see if you're getting the correct output. Okay, so basically object-oriented programming is nothing but where you model your real world, okay, so that you can build and test your solutions. Now when to model, like for example, when we took the example of an architect, How did he model? There were two ways, right? Either he would use a traditional cardboard to model his design, or else he would use a software to to create a 3D animations out of it, right? Now, as in object-oriented programming, what we use is our tools are nothing but classes and objects. So basically, we are going to use classes and objects, okay, to model the real world. Now, what does this even mean? This means that classes are going to be used as blueprints, okay, and objects are going to be used as instances of those classes. Now again, what does this mean? Okay, till now what we just saw, we saw that object-oriented programming is a programming paradigm which helps us to model the real world so that we can solve problems for the real world, right? Second thing, it's based on the concept of classes and objects. That means we model this real world by using classes and objects. In other words, you take any real world entity, right? Now, when you say real world entity, we actually refer to two kinds of things. One is a physical entity. Physical entity is something which I can touch and feel. And I have something called as a logical entity. Logical entity can be something like an bank account, right? I can't actually go and touch a bank account, right? That is not possible. It's just a logical concept. Yes, you do get a bank account, checking book and everything, but it's still a logical concept, right? So when you say that whatever, let's say you're trying to, whatever real world, model you have, whether it can be a physical entity or a logical entity like a bank account, we try to convert this, we try to model this in our software, okay, using what object oriented programming principles by creating classes and objects for it. Okay, so now classes actually act as blueprint. Now what does blueprint mean here? Now for example, let's take an example of the architect again, right? Now let's say the architect creates a blueprint, okay, I mean he creates a model, right, or a 3D animation. Now that can be considered as a blueprint. Okay, now let's say the client who had given him the contract of, designing a corporate office, might be he wants to have the same corporate office in, let's say, 10 different locations. Possible? Yes, when you have a brand, mostly they want their offices to look very similar. So might be now the contractor or the client says that whatever design you have done is great. And now I want you to, have the same design at 10 different locations, correct? So whatever design, whatever model the architect has created can be considered as a blueprint, right? Now we can give this blueprint to the constructors, right, who are actually going to construct the building, and they are going to create what? 10 different instances of that blueprint. So that is nothing but objects. That's the concept of objects. I hope that is clear. Let's go through it again. So when I say classes, classes is nothing but can be considered as blueprint. In other words, classes is nothing but it's basically whatever, let's say you have any entity, right? Basically physical or a logical entity which you want to model in your software world. If you want to do so, now you will be, when you say any physical entity or logic, let's take an example of a bank account, right? Because I hope everybody knows what a bank account is, right? So when you have a bank account, what are the things you can do with the bank account, right? Every bank account will have some properties and there'll be some operations which you can perform on a bank account, correct? Properties would be like what is the, like which bank this bank account belongs to, whether it's a checking account or whether it's a savings account or whether it's a loan account, like so many different accounts you have in a bank, right? What is the account number, who's the owner of the account, right? So many different things. Those are nothing but the properties of a bank account. What are different operations you can perform? Operations means you can open a bank account, you can withdraw money in a bank account, right? You can deposit money into a bank account. These are different operations which you can perform on that entity. Same thing you can do for a physical entity as well, right? I can say that car can be my example of a physical entity. Now for a car, you can have different properties. What are the properties? What is the name of the car, right? Which brand it does it belong to? What is the model? Like even if I say that it's I'm choosing a BMW car, there will be different models in BMW, right? So which exactly model you're talking about, right? What is the color of the car? What is the mileage and so on, right? And then you have operations which you can perform on this physical entity, like you can drive a car, right? You can actually you will want to add fuel into the car and so on, right? So there are different operations which you can perform on the entity, right? Now what is this? when you say about a particular entity, the details regarding its properties and operations. Details as mean what all properties you want to capture of that entity and what all operations you want that entity to perform. This collection of these properties and operations is nothing but called as blueprint, or in other words, a very classy name given to it is class. So class is nothing but blueprint for the entity which you're trying to model. It basically has two important things. One is what are the properties of that entity which you want to capture in the software. And second thing is what are different operations you can perform on this entity. All this thing has been put together under something called as class. Okay, I hope this makes sense. Now, if this is a class, what is an instance? Or what is an object? An object is basically called as an instance of a class. Now, usually I have students who do not understand what does instance of a class means. That's okay, it's just a textbook definition. Let's understand what it really means, right? When I say instance of a class, when I say object of a class, it simply means that, see, what is a blueprint? Blueprint is nothing but, or a class is nothing but, what are properties and operations I want to capture of that entity, correct? Let's assume we take a physical entity, car, for which I'm going to create a blueprint. So I decide for this car entity, the properties I want to capture in my software is only I want the name of the car, right? And might be I want the color of the car. And the operations in which I am, interested in is only the operation of driving my car, right? That's the only operation I want. This is my property, this is the operation, correct? Now tell me, this means that for if I create, okay, let's say when you have a car, you can have different types of car, right? Let's say you have two different cars, right? Now now do you have any data here? Do you have like, okay, you know that this car, when you say a car as a class or car as a blueprint, you know that you have to capture all this information and this is the operation which you can perform on this properties, correct? But do you have the data here? No, right? So tomorrow, now when you see, let's say you've modeled this as part of your software, correct? Now how do I test my software? Let's say you wrote beautiful code and everything and now you want to test this, correct? That's what you usually do with your software. So if you have to test this, I need to provide some data, correct? So let's say I have going to create an instance of my BMW car. Let's say the name of my car is going to be BMW. Let's say I have color black. Okay. Another car I have might be it's Audi, and let's say the color of my car is red. So what are this? This is nothing but this is nothing but an instance of this class. This is the second instance of this class. In other words, is whenever you put data inside the blueprint, right? Like what is this? This name is corresponding to BMW, color is corresponding to black. So when you put data inside this blueprint, it becomes an instance of that class. In other words, you have now, so basically you're saying that you have captured what? Car as an entity, and specifically for this you have captured, you are interested only in two of the properties of this car entity. So let's say if I have two entities of car, this is also a car, this is also a car, how do I basically separate between the two? Because this is a different basic entire entity altogether, right? For example, how we have in real life, two human beings are never same, right? Because why two human beings are not same? Because we have a different name, we have a different identity, right? We belong to a different country, so everything is different, right? But the properties of two human beings is going to be same, more or less going to be same. Only what changes is the data which is there, like in the product. My name would be different from your name, my age would be different from yours, my birth country would be different from yours. So the different properties, I mean the data which I fill in these properties is going to make me unique as a human being. Similarly, in the car example, whatever data you fill in this blueprint, that is going to make your particular object of this car as unique. So what is an object? An object, a fancy definition, it's an instance of a class. If that you do not understand, simply understand that is, you are saying you are going to capture this car entity, right, in your software, and you want this information of name and color. So whenever you have to create an object of the car class, is nothing but you put the values of this of this properties and you create a object out of it. So right now for this car class, I have two objects. One is the car, but let me call this as object 1, which has values name equal to BMW and color equal to black. This will also be able to drive. All right, and then I have a second object, object 2, and which will have the name of the car as Audi and the color is red, and let's say it also will have this driving capacity. Okay, do you understand this? This is what a class as an object is. When you say object oriented programming, It is completely based upon you have to model the real world so that you can build and test solutions on it, and it is completely based on classes and objects. Okay, so now the entire object oriented is nothing but how these classes and objects are going to interact with each other such that we can actually mimic the real world problem. And then once you can mimic the real world problem, you definitely have a way to find solutions, and that's how you create a software which solves our real world problems. Okay, I hope this helps. So the next we're going to do is, now because as I mentioned, I will be walking you through OOPS concept by Java language. So let's try and create a simple class. Okay, and let's create these two objects, let's say BMW and Audi. Let's do that. So this is my IntelliJ. So I've created a class car, right? So might be now you do not understand the word public. It's totally fine. We are going to come and see what does public means. So right now you can just ignore it. Just say we have a class and car. This is the name of my class. So this is open and close parenthesis saying that this is whatever information I need, whatever blueprint I need about this car entity will be put inside. So here I'm going to capture two properties. So obviously I hope everybody knows what, I'm assuming that you at least know what a Java language is, right? At least one of the one of the programming language. So with that, so I'm saying that the name of my car should be of type data type string. Color is again should be of data type string. So these two are nothing but my properties of the class, right? In other words, it's basically data types, or these are data members of my class. The reason I'm calling it as data members, so let me write that word I'm saying here, this is data members of my class. And it makes sense, right? The word data is because this is the place, these are the placeholders where I'm going to put actual data when I create an object or an instance of that class, right? Blueprint is going to tell you what all information you're supposed to collect for this particular class. Okay. Then in the case of behavior, or we can say what all operations you can perform on this particular class, right? Your methods is nothing called as a method. A method is nothing but what all operations, okay, what all operations you can perform on this data, right? So you can basically drive this car, right? So what are the operations? Are nothing but called as methods of the class. This is nothing but the behavior of your class, right? So I can say behavior as in when you have a car, you're supposed to drive the car, right? If it's a bank account, you can withdraw money and deposit money into the bank account. That becomes the behavior of the operations which you can perform on that entity. Okay, so that is nothing but called as methods when it comes to object oriented programming, right? So here I have basically drive, which is the name of my method, right? And it's going to not return anything, so it's void type. And I've simply written here, I just wanted to show a dummy this, so I just written here that it's going to be driving my car. Now here I'm actually going to create my object. I hope this is visible. This is I'm going to create my objects. Let me say the name of my object is BMW. So I'm going to say new car. I can create my second object here. Let's say Audi, and I can say new car. Correct? So how many objects do I have of this, class car? I have two objects here, correct? BMW and Audi. In the next subsequent lectures, we are going to now see how now you have just created this instance or an object of the class, right? We haven't really added data to that particular objects. So let's try to put data here. So the first thing I want, BMW dot. So if you can see, when you create an instance or an object of the class, you can actually access all the members of this class, right? Every class will have two things. One is the data members and second is your methods. So you can access both via the objects. So when I say BMW, as you say dot, I can have color and name. So let me first initialize with my name. I want to give a name as, let's say it's BMW. Okay, so that basically I'm now adding data to my object. So now I'm going to say BMW dot, I want to mention the color. Let us have a black color. You can mention any color you like. So let's say black. The next is, so this is basically my object is created and I've also assigned value to the different properties for my object BMW. Similarly, I'm going to do it for my Audi. I'm going to say Audi dot, I can say name is equal to Audi. And the second one is Audi dot, and let's say color, and let's say I want to go with red. All right. So I have now, basically two objects created here. Let's try to call the methods of this objects. So I can say BMW dot drive, okay, and let me also call Audi dot drive, right? That means there are these two instances of the class car, and I am basically adding properties and this can you see I had called it BMW dot drive, and it's again saying driving my car. Let's see Yes, and you can also see the second one, which is driving my car, because both of them are calling the same method, right? So I hope this is just a small demonstration to show you what classes and objects actually look like in Java. Hope this helps.